All right, so let's try a few more examples using the equations or formulas. This first one, let f of x equal 1 over x plus 2 minus 1. So you're going to find f of 0. So this is finding the output value because you're given x equals 0. So you'll plug that in and get your y value. And this one is saying if y is equal to 0. So you'll set this equal to 0 and then solve for x. So go ahead and pause the video, see if you can work that out, and then we'll come back and do this together. All right, so find f of 0. Put this over here so I have a little bit of room to work. So f of 0 is 1 over 0 plus 2 minus 1. So just put the 0 in for x. And that's going to give me 1/2 minus 1. And that's equal to negative 1/2. So there is my answer. That's my y value. So if I was going to plot this on a graph, when x is 0, y is a negative 1/2. So it'd be like somewhere right around there. Okay, so it's kind of an interpretation of what we're looking at. And then solve f of x equal to 0. So I have 1 over x plus 2 minus 1 is equal to 0. My first step, I'm going to add this 1 over to the other side. So I have 1 over x plus 2 is equal to 1. So it's looking a little better. And I need to get this x out of the denominator so I can actually solve for it. So what I'm going to do is I'm going to multiply both sides by the quantity x plus 2 in parentheses there. So those will cancel out and I get 1 is equal to, and then 1 times anything is just this anything. So I get x plus 2. And then if I subtract 2 from both sides, I'm going to get x is equal to negative 1. Okay, so as far as the graph goes, that would be this point, negative 1, 0, somewhere right around there. Right, and then number 6. So this one, I apologize, this has got definitely some fraction work here. I'm going to work through this one with you. So f of x is x over x plus 1. And for x, what we're going to substitute in is 1 over a plus 1. So you'd see probably the most important thing is to be really careful making this substitution in so that then all the algebra that follows will be correct. So if you make a mistake plugging it in, then all the work that you do afterwards, you would get credit for as long as the work is correct, but you're not going to wind up with the right answer because you had a misstep plugging things in. So f of 1 over a plus 1, I'm going to replace this x with 1 over a plus 1. I'm going to put all of that over 1 over a plus 1 plus 1. Right, so that's what it looks like if I just plug it in. And that's certainly, this is a good step right here. And we need to condense it down to it's just a single fraction, so something over something else. There's several different ways of doing this. One would be to create this to have the same denominator as these other pieces. I'm going to go a little different approach, and as long as you're still getting to the same place and you're using valid algebra, that's totally fine. So let me show you. This is kind of my favorite approach. What I see is I don't want this a plus 1 here. I don't want this a plus 1 down here. Those are both kind of causing problems. So what I'm going to do is multiply through by a plus 1 over a plus 1. And that's because this thing here is equal to 1. And anytime you multiply by 1, you haven't changed the value of what you have. So if I multiply through, what I have is a plus 1 over a plus 1, which is just going to be 1. So that's awesome. And then this needs to get distributed to both of these terms. So I get a plus 1 over a plus 1 plus this quantity of a plus 1 here, because 1 times that gives me an a plus 1. So I get 1 over 1 plus the a plus 1, because that guy's 1 and this one's 1. And so that gives me 1 over a plus 2. Okay, so that's one way of tackling it. The other one that I talked about a minute ago was doing this common denominator thing. So let's actually take a look at that so you can see what that looks like. So I have 1 over a plus 1 over 1 over a plus 1. And then I'm going to switch out this 1 with a plus 1 over a plus 1. Right? So now everything has the same denominator. We have 1 over a plus 1 over 1 plus a plus 1 over a plus 1. So I combine those two numerators there. Get 1 over a plus 1 over a plus 2 over a plus 1. Okay. And then I have this same number here and here. So you can actually cancel those out. And if you want to understand why, that would be because when you divide two fractions, you multiply by the reciprocal. So that means instead of saying this divided by this, what I'm going to do is I'm going to flip this guy over and multiply. So I get a plus 2 over a plus 1, like that. And those a plus 1s cancel. And I'm left with 1 over a plus 2. Okay, so either way, you're going to get to the right answer. And it doesn't matter which way you use. I just wanted to show you two different ways. Right? And then at the bottom of this page, what I've done is I've summarized kind of everything we've done. So I've put your definition of the output value. Okay. And I've talked about how to do it for a formula, table, and graph, and then similarly for an input value. So rather than flipping through all your notes to find the box you're looking for, I did put them all together here for you at the end. All right, so that is the end of 2.1, and I will see you back for 2.2 where we talk about domain and range.